working with Python string sequences and functions. As we can see here, a Python string is a zero-based sequence of characters. See below, for example, string Python, characters P, Y, T, H, O, N correlate to an index in this order: 0, 1, 2, 3, 4, 5. If we want to print the letter H, we can access a character in the string by referencing index 3. For example, we can create a variable, give it the value Python, and then we print var1 of 3, run the program. It displays the letter H. If we want to iterate a string or access each character with a loop, we can do that. We can create a for loop for s and var1 print s, and this should print python in a new line for each character as follows. And that's what we get, a letter in each line. We can also iterate a string with a while loop. This is where we introduce the concept of the length function, which returns the length of a string. We create an index variable, index equals 0. We create the while loop while index less than the length of the string, which is var1, and we want to print var1 of index plus equals 1 to increment the index, and we run the program and we get the same result. However, I briefly wanted to review what is going on in the loop. If we look at example 3 in the solution file, iterate a string sequence with a while loop. The index value after each iteration increases. It starts at 0, proceeds to be 1, 2, 3, 4, 5. However, what we want to do is look at how we're calling and collecting data from the string. So var1 of 0, the value is p. var1 of 1, the value is 1. And that is var1 of bracket number, close bracket, in this case number 2, t, var1 of bracket, open bracket, 3, close bracket, and h, and then 4 and 5. This is how you can iterate through a string with a while loop. We can also concatenate strings. We have var1 equals Python. We can create a new variable, var2 equals is great. We print var1 plus var2. This plus sign tells the Python interpreter to put the strings together, and then we send it to the print function, and the result is Python is great. We can also concatenate strings in a loop. For example, example number 5, numbers equals empty string. For I, that's the target variable, in range 10, we want to iterate 10 times, and we want to concatenate I, convert it to string. After the loop exits, we want to print the result. And that's the result we expect. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let me review this concept. It's important in computer science, and in this case in Python. We have strings, the immutable concept. In Python, strings are immutable, and once they are created, they can't be changed. And that means in memory, they can't be changed. We can see them change, however, they can't change. Explaining this concept is easier with a diagram. var1 references the string Python. var1 equals Python. var1 references the string Python. So this is how we will look at memory. The variable var1 points to some space of memory that has a sequence Python. Now, if we want to create var2 equals is great, and then we want var1 equals var1 plus var2, what we are doing is we are creating two string literals in memory and concatenating them. The final result is a Python string sequence. Python exists somewhere in Python's memory, however no variable references. Instead, var1 points to a new string reference. With the string sequence, Python is great. So that's an important concept to understand. This is important, especially if we're going to be dealing with data conversions where we have to manipulate a lot of strings. We have to be careful with this because it's memory intensive. We move on to string slicing. String slicing is a concept that allows us to select a range of characters from a string. And the way we do that is, first of all, the structure is we start with a string, open bracket, start, and then colon, and then end, and then close bracket. What does that mean? If we have var1 equals Python is great, we can print Python by doing print, open parentheses, var1, open bracket, and then colon, and then 6, and this will print Python. That's what we expect. Notice that it knows that we want to start from the beginning if we leave the start empty. If we want to print is, we can do print, open parentheses, var1, bracket, 7 to 9, meaning 1, 2, 3, 4, 5, 6, 7, 8, and it's 0 index, so 0, 1, 2, 3, 4, 5, 6, 7 is going to start here and it's going to go to here. And then we'll see this. We can also print great, if we do print, open parentheses, var1, -5, meaning we want to start at -5, which means it'll start from here and count 5 spaces back. And then again we see that it knows that we want to go to the beginning of the string, and that'll print great. Another thing we can do with string slicing is we can print every other character in the string. How do we do that? We create variable numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9. print numbers. We have start, meaning from the beginning to the end. We don't put anything in the second slot. However, we have the step, the third parameter, which is a step argument, and the result will be 1, 3, 5, 7, 9. We can also print a string in reverse. We have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and if we do print numbers of -1, meaning from beginning to end, but in reverse, then we should see 9, 8, 7, 6, 5, 4, 3, 2, 1, and that's the case. These are short examples for using string slicing. You can also test for strings or search strings. For example, we have var1 equals Python is great, and we can use is, the value is, and the string is, in var1 we want to print found, else we want to print not found. We run this piece of code and it exists. Now, if we want to negate that, we can do not in. And what this means is it'll negate it. So if it is, then it should go not found. And it does. So negation can help us when we want to negate values in Python. We move on to validating data with strings. And we have strings which have functions that return a value or manipulate the string. These functions are useful for various tasks. One of the tasks is data validation. For example, we can create a value returning function to validate that a string is numeric and is greater than 0, but less than or equal to 100. We create def is data numeric, and in range we pass it a value. Here we can put is data value. That makes more sense. If not, value that is digit, we want to return false. Elif not int of value greater than 0 and int value less than or equal to 100, we want to return false, else we want to return true. We capture data from keyboard, num equals input, enter number, we call the function if is data valid num parameter or argument in this case, print valid data, else print invalid data. We proceed to run the program. Round number 50, we have valid data, run it again, 150, invalid data. This is how we could build value returning functions to validate the data. Example, with strings, we can also have var1 equals Python is great, and we can print var1.lower displays Python is great in lowercase, and that's what we get. We can do print var1.upper displays Python is great capitalized. Finally, we do var1.title displays Python is great with each, or in title case. In this case, the first letter of each word capitalized. We can also, example 14, search a string with string functions. For example, we have var1 equals Python is great if var1 dot ends with at, print ends with at. We run this piece of code, and it ends with at. We can also compare or find characters. Now equals -1, so if it doesn't return -1, it means it found some data, and then we can print found. We run this piece of code, and it found is in Python is great. We can also print var1 dot replace, and we want to say that Python is not great, but Python is the best. We send it the current, or what we want to replace, which is great, with the new string, which is best. We run this piece of code, and now displays Python is best. The last example is var1 starts with py, print starts with py. We run this piece of code, and it is beginning with py, thus it displays starts with py. And this was a brief overview of working with string functions and string data validation in Python.